Okay, so we're going to look at dilations, and I will say that they tend to make this section a little harder than it should be, and so I'm going to simplify some things for you. But let's start with some review. So go ahead and answer questions 1 and 2. On your own, let's go. So your 4 isometries, the T is and the first R, we'll go with rotation. It could have been what else? So these are in any order. And then what's the G? Then circle the correct answer to complete the sentence. A mapping that results in a change in the position. Let's do pink. A change in the position, size, or shape. Position, size, or shape of a geometric figure is called a... Why is it not an isometry? What do these things do? Do they result in a position change? Sure, they could. What about a size change or a shape change? These do not make size or shape changes, and those are isometries. In other words, they're rigid motions, and rigid motions do not do size or shape changes. So it cannot be an isometry. Why can it not be congruence? That's also rigid motion, right? Isometries give you congruent figures, and so your only thing that's left is a transformation. And there are, according to this chapter, there are 5 different transformations. There's a translation, a rotation, a reflection, a glide reflection, and what we're doing today, a dilation. And so that dilation is also considered a transformation because it's transforming the figure in some manner. It just does not give us a congruent transformation. It is not a rigid motion. And so with scale factors, we're going to use, with dilations, we're going to use what's called a scale factor. And it's kind of based upon what Olivia was asking today on your homework from the previous night, was how do you change, a room that's 12 feet by 16 feet to inches on your paper, and that was using that ratio of 1/4 inch to 1 foot, and that's a scale factor. And so we were taking the size of a room, 12 feet, Ian, head up, 12 feet by 16 feet, and we were scaling that down to inches on a paper. So that's a scale factor. That dilation shrunk the room into a size that fit onto the paper. And so that's what we're going to work with today. The definition of a scale factor of a dilation is the ratio of the length of the pre-image to this corresponding length of the image. Now, I don't like the way they said this because it says length of pre-image to the corresponding length of the image. So the way they wrote that with a ratio means it would be pre-image over image. But then note what they said here, with the image length always in the numerator. So it's the image divided by the pre-image. So they really should have said it's the length of the image to the corresponding length in the pre-image. It's the way they should have written it. So in 3, this is a tough one. Circle which of the following shows a dilation. Is it the first, the second, the third, or more than one? The first is definitely a dilation. It went from a bigger skateboard to a smaller skateboard. But don't the rings look identical in size? They've just turned. And then the skates are identical in size, so they haven't changed. So when a figure is transformed by a congruence transformation, what are your congruence transformations, by the way? What's a congruence transformation? What gives you congruent figures? What kind of transformations? rigid motion, which are all the isometries we talked about above, right? Translations, rotations, reflections, and glide reflections. So when a figure is transformed by those, what is true about the corresponding angles and the corresponding sides of the image and the pre-image? So in non-dilations, translations, rotations, reflections, glide reflections, what is true about the corresponding angles and the corresponding sides? They maintain that distance and angle, right? So the corresponding sides and angles remain congruent. All right, so let's look at page 2. Here's where they start in some, their key concept dilation here looks a little confusing. You do have a center of your dilation. The center of the dilation is in the center of the figure. And so if I were to move this into the center of the figure, it'd be somewhere around here. Now what you think of as the center of the figure and what is actually the center of the figure could be different because of how weird the figure's shaped. You'll see as we do some of these, that's not necessarily what you think it is. But that's neither here nor there. On number 5, question 5 right here, they're asking you to show the equation that's true for the dilation. Now remember that they're trying to give you what's called a scale factor. What did we say on the other page about the scale factor? It's what over what? Yeah, so your scale factor is equal to image over pre-image. Now when they're using primes, the primes belong to the image or the pre-image? The image. And so you're looking for the prime to be up top on the non-prime to be in the denominator. So they're looking at CX and CY. So if you look at this figure, here's C, and they're saying that C prime and C are the same because that's the center of the dilation, so that's why they're calling it C. And so they're one and the same. So this distance from C to P should be in proportion to the distance from C to P prime. C to R is in proportion from C to R prime. And so as you look at this figure down here, which deals with X, Y's, and Z's, along with C, that center of the dilation, C to X is in proportion to C to X prime. But you have to have the image over the pre-image. So as we look at this, is this the image, the CX, is that the image or the pre-image? CX. Pre-image. So is this the right ratio? Because we've got CX and CX prime, that's from C to X and from C to X prime. Those are the two sides that correspond if you were to make triangles out of this dilation. But they've got the CX in the wrong place. These need to be switched. So this cannot be one of our ratios. What about this one? Is that in the right order? Yeah. So this is an acceptable scale factor. What's wrong with this one? CY over CY prime. The image or the pre-image is over the image because the pre-image is up top on that one. And then what's wrong with this one? They finally have the image up top. But what's wrong with the CX versus the CY prime? They don't correspond to each other. So those are your reasons for those. And by the way, the reason why they are not attaching a prime to the C is because C and C prime are one and the same. So you could put C prime, X prime here if you wanted to. They're one and the same. They chose to just leave it as C. So also keep that in mind. So let's look at number 1. They're going to go into some convoluted ways to find the scale factor, and we're going to cross out some of this because it's much easier than what they make it look. So you've got this figure here versus this figure here. So which was the original figure? The black or the bluish green, whatever that is, the turquoise one? The black. And so how many of you have ever gone to the eye doctor and gotten your eyes dilated? Okay, what gets dilated in your eyes? Your pupils. Did they get bigger or smaller? They got quite a bit larger, didn't they? And so a lot of us think that dilations mean that they got larger, that something gets larger. But a dilation in geometry means that it can get smaller too. A dilation just means a change in size. So this is a reduction, isn't it? So your dilations can be reductions or they can be enlargements. So this happens to be a reduction. And so question number 6 says the image J prime, K prime, L prime is smaller than the pre-image J, K, L, M. So that means that the image is a reduction. And then we're going to find the ordered pairs of plane J, K, L, and M. So please find those ordered pairs for me and write those in. Bless you. So find your proper ordered pairs. And then I want you to find the ordered pairs of J prime, K prime, L prime, and M prime, please. All right, so do we agree on our ordered pairs? Okay, so that's your first step. Your second step is to take one set of ordered pairs. So I'm going to take this set for a very good reason. First of all, I want you to cross out number 10. That's ridiculous. We don't need to use the distance formula. If you look at this, which one of the two is your image? Because remember, our image needs to go up top. Is it the primes or the non-primes? The primes. So if you took your ordered pair 3, negative 2, and you put that over the other ordered pair 6, negative 4. So I essentially have my image up top and I've divided it by my pre-image. Agreed? What do you notice about 3 over 6 and negative 2 over negative 4? It reduces to 1/2, 1/2, doesn't it? Don't they both have the same, what I would call the scale factor? That's all you have to do to find the scale factor. Then just make sure. So essentially I'm taking the pre-image right here, and aren't I dividing it by 2 to get to the image? Do that to every single one of these. If I divide this by 2, I get 0. Divide that by 2, I get 1. Divide by 2, I get 3. Divide by 2, I get 0. Divide by 2, I get a negative 1. Divide by 2, I get a negative 1. Doesn't it work for each and every one? So you want to double check once you find your scale factor. So this right here, just one of them, becomes my scale factor. So when they ask for that scale factor, that's all you have to do. But do make sure it works with all of your ordered pairs in the figure, because you might have made a mistake. Or it's possible it's not a true dilation because not all ordered pairs on the figure were dilated the same with the same scale factor. So all you have to do down below here is put your 1 and your 2. Well, I think they wanted really was the original distance, but we don't need the original distance. This is good enough for our scale factor. And so don't go through all that extra math. That's crazy. All right, so then let's look at problem 2 on the next page. So you're going to find a dilation image. What are the coordinates of the vertices of D? And so now you can see this change in notation. So as you look at the notation, we're now using capital D for dilation, so that makes sense. What is this right here? What's that going to be? The scale factor, and that's what we're doing to the pre-image. So we're essentially multiplying the pre-image by the scale factor. So you're always taking your pre-image and multiplying it by the scale factor. And then this is what we are dilating here. And so they have kindly plotted for us here our PZG. And so if I were you, I would write out, and you kind of see what they're doing here, I would write out my ordered pairs for P, Z, and G. And then they want you to answer the center of the dilation is the blank and the scale factor is the blank. They don't tell you what the center is right here. The assumption is that it's the origin. And in my opinion, they really should write it out this way, because technically your center could be, I don't know, the ordered pair 2, 4. It depends on where that figure is in the coordinate grid. But for your purposes in this class, it's going to be the origin typically. And so in my opinion, they should have written it this way: 1/2 comma O for origin. And then, I don't know, they can do it like that. And then this is the figure that we're dilating. Do you see how that does not look like the center of the figure? Right? But wait till you see the dilation. So let's go ahead and, so the dilation is the origin. I'm sorry, the center is the origin. And the scale factor is 1/2. So since we're multiplying by 1/2, are we going to have an enlargement or a reduction? If you multiply something by 1/2, it's going to cut it in half, right? So it's going to get smaller. So a reduction makes sense. So your resulting figure should be smaller. So let's go ahead and start with our ordered pairs. What is the ordered pair for P? Your X value is 2 and your Y value is 0. What about for Z? X value is what? -3. Y is 1. And for D? G. 0, because you're not going right or left at all. So be careful with points that are on the X or the Y axis that you write the order pair correctly. So 0, -2. Now some of these are not going to be so easy to take half of. And so our new ordered pair, P prime, Z prime, and G prime, end up being the following. So we're going to take half of 2, which is 1, and half of 0, which is 0. So we're going to plot that ordered pair to the right one up 0. And this ends up being P prime. And then half of -3 is -3 halves, which in mixed number terms is -1.5. And then what's half of 1? 1/2. So that's not a fun one to plot. So you're going to go to the left 1.5 and up 1/2. So it kind of puts us right there. And so that is Z prime. And then for G prime, half of 0 is 0, and half of -2 is -1. So you're not going to go right or left, you're just going to go down 1. And so this becomes G prime. And if you connect with a straight edge, I can't do it up here, but if you connect with a straight edge, this did become a reduction. Funny, right? Isn't that odd? Very strange. All right, so then problem 3. Funny that. Problem 3 says using a scale factor to find a length. So the height of a document on your computer screen is 20.4 centimeters. So that's an important piece of information. That's the height. When you change the zoom setting on your screen from 100% to 25%, the new image of your document is a dilation of the previous image with a scale factor of 0.25. So what is the height of the new image? So do we have an enlargement or a reduction? A reduction again, because our scale factor is less than 100%. And then what are you putting here? This is the actual length, right? So what goes here? What's that called? The image. So you could put image there. And so we'll go ahead and put image length. So image length to actual length should equal 0.25 to 1. The image length is going to be 0.25 of the whole actual length. And so what they've done here, again, which is maybe making it more complicated than it needs to be, they've taken the fact that you have a proportion here, and haven't they cross-multiplied? Image length times 1 got you to image length, and actual length times 0.25 got you to scale factor times the actual length. So this right here is your scale factor. And so we're just going to fill in our information that we have. So our scale factor is 0.25, and then our actual length is 20.4 centimeters. So multiply 20.4 times 0.25 with your handy dandy calculator, and you get 5.1 centimeters. Now how could you check that? How could you check it? Take your image and put it over your pre-image, because remember, your image over your pre-image should equal your scale factor, right? So if we took, there's our scale factor, if we took our image, which was 5.1, and if we put that over our pre-image, which was 20.4, if you took that on your calculator and divided it, you're going to get 0.25. And so you end up with 0.25 is equal to 0.25. And so it checks. So this is your check. Okay, so you ought to be able to check that. All right, then let's go to the last page. Let's see if you, oops, I certainly didn't want to draw a line. All right, so you do your lesson check on your own. So do it by yourself first, and then I'll let you chat with somebody. Okay, so chat with somebody around you. See if they agree with your conclusion. All right, so let's look at what you have and let's talk about the results. So the image has the primes, even though the A does not. It's because the image and the pre-image both share the point A because they're overlapping triangles. And then this is your pre-image. And so AB corresponds to AB prime, AC corresponds to AC prime, and BC corresponds to B prime C. Then find your side lengths. The side lengths from A to B prime, so that's pretty simple, just 2. But here's where the student made an error, right? Is the side length from A to B is not 6, isn't it 2 plus 6 to get that 8? And then the side length for AC, that's easy, that's 1. But the side length for from A to C prime, the side length from A to C is your 1 plus 3, which is 4. So when the students calculated the scale factor, they took the 2 over the 6. And the 6 is not the length of the pre-image, is it? And so that's where their problem was from the very beginning. And so down here, if you took the image over the pre-image, which should have been 8, not 6, then you get 1:4. And same thing over here on the other side. Here's the image and here's the pre-image, so 1:4. And so my response would be the student, and yours can just be similar, it doesn't have to be the same. The student did not find the correct length of the pre-image when using it to find the scale factor.